T11.11. A government report says that the average amount of money spent per U.S. household per week on food is about $158. A random sample of 50 households in a small city is selected, and their weekly spending on food is recorded. The sample data have a mean of 165 and a standard deviation of $32. Is there convincing evidence that the mean weekly spending on food in this city differs from the national figure of 158? Okay, all right, so 158 is our null value or claim. 50 is our sample size. 165 is our sample mean, x bar. 32 is the standard deviation. Am I missing anything? I think that's it. Okay. All right. Part A, state appropriate hypotheses for performing a significance test in this setting. Be sure to define the parameter of interest. Okay, so the parameter of interest is, let's write it like this. So mu is the notation, and it's the true mean weekly spending on food in this particular city. Right? We don't know the name of the city, but it's just the city that sample came from. Okay. All right, and then the hypotheses, so the null hypothesis, let's write hypotheses. All right, so the null hypothesis would be that the true mean in this city is the same as the national figure 158. The alternative, it says differs here. Okay, so the alternative is that mu, the true mean spending in this city, is different than the national figure 158. So this would be a two-sided test. All right, so that's part A. Part B. The distribution of household spending in this small city is heavily skewed to the right. So they're describing the population, the shape of the population. Okay. Explain why the normal/large sample condition is met in this case. Okay. Well, even though the population is non-normal, we have a large sample size. So the central limit theorem guarantees that the sampling distribution will be approximately normal. Okay, so part B. Because n equals 50, which is greater than or equal to 30, central limit theorem guarantees that the sampling distribution of x bar will be approximately normal, right? And that's the distribution we care about, right? We don't care that much about the population distribution. However, if the population was approximately normal, then that shape would carry over to the sampling distribution. Okay, but if the population is non-normal, as long as you have a big enough sample size, the sampling distribution will be approximately normal, and that's what we care about. Okay. Part C, p-value for the test is 0.128. Interpret this value. What conclusion would you make? All right, so to interpret a p-value, we would say something along the lines of, if the null hypothesis is true, meaning that the true mean in this city is the same as the national figure, then there's a 0.128 probability of getting the observed result, right, which was a sample mean of 165, or more extreme, purely by chance. Okay, now the likelihood or probability, that's about 12%, which is not like low enough for it to be significant. It's not low enough to be suspicious. I don't think this problem gives us a significance level, but I would just go with 5%. This is not below 5%. All right, so since 0.128 is greater than 5%, we fail to reject the null hypothesis. So we do not have convincing evidence that, okay, now I gotta add in the context, and I'm just gonna borrow from the question stem, that the mean weekly spending on food in the city differs from the national figure of 158. The mean weekly spending on food in this city differs from the national figure of $158. Right. So in other words, the difference that we're seeing, this 165 versus 158, it's just random variation, right? It's nothing significant.